To do another video about section 5.1 and the different forms for quadratic functions. So we're going to have the standard form, which is the ax squared plus bx plus c form. We're going to have, sorry, that's the general form. The standard form, I often call it the completed the square form, which is when you do some algebra to change it into the a times x minus h squared plus k form. And that lets you find the vertex easily. It lets you figure out how it's been shifted left and right and up and down by h and k. And the third form is with a factored form, when you can factor the quadratic equation and get something of the form a times x minus one value of x times x minus the other value of x, the two zeros. And so if you have it in that form, it's easy to find when it's equal to 0. So let me give you an example. There are three types of problems that you'll be trying to solve with quadratic functions typically. One is to find the y-intercept, find the value when x equals 0. It's often the starting height or the starting price or something like that. And if you have it in the general form, the ax squared plus bx plus c, that's just c, and that's easy. In the other forms, you plug in x equals 0. But in this form, you can read the number off the formula. And so that will find us the y-intercept. Another thing you might be interested in finding is find the maximum or minimum for a value. So find the highest point, which would be the maximum profit, or find the lowest point, which might be the minimum cost, or something like that. And so in the book, they describe, if you have it in the general form, ax squared plus bx plus c, the vertex of the parabola is at x equals negative b over 2a. And that little formula you can memorize, and it's pretty easy to calculate. Or if you can change it by completing the square to get the form a times x minus h squared plus k, then it's easy to read off the value for the vertex hk. Conversely, if you know you have a graph and you know it has a vertex at hk, you can write down the completed the square form easily. So that's a nice way to go. The third thing you might try and solve for is when is the function equal to 0? And so that's just, the easiest way to find that is if you have the factored form of the equation. So if you can factor the quadratic function, then one term is equal to 0 or the other term is equal to 0, and you can solve for x's. If you can't factor it easily, you can also solve it from the a times x minus h squared plus k, the completed the square form. And in fact, solving it like that gives you a third equation, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula. And that is another example. And it actually, you can memorize that, or it comes from solving the completed the square form. So I'll show you how that works. So the hardest part about this, so there's two hard parts. One is how to complete the square and get it into the other form. So if you have an equation in the form ax squared plus bx plus ax squared plus bx plus c, and you want to switch it to the completed the square form so you can find the vertex. Here's how you do it, and then I'll explain how this works. So what you start with is the formula that you've got. And to begin, you move the negative 30 off to the side. You don't want to worry about that constant for a second. And you're going to complete the square by plugging in some number here. And it's always take half of this. First thing first. You factor out the 2. And you can leave the 30 out there. And then you have to complete the square by plugging in what goes there. And it's always take half of that middle coefficient and then square it, or so divide it by 2. So I did say half. Take half of that, square it, and so you get, in this case, 2 over 2 squared. And then since you added that into your function, you have to subtract it out here. But we actually added 2 times that function. We had this 2 out in front. So in our case, we have to subtract 2 times that little half of b squared term. And so then the reason you do that is that sets up so that this expression, you plugged in that red 2 over 2 squared to complete the square. That now factors into x plus 1 squared. And I'll show how that works in a second. So you've completed the square, and when you do that, it's easy to read out that the vertex is at the point -1, -32, which it is up, if you look at the graph up above. So the vertex is down there. So why do you do that procedure? Well, the easiest way to explain why you do that procedure is it's reversing the multiplying out form. So if you start with, up here, you start with something in the completed the square form, how do you get back to the general form? You just multiply things out. So you square the x minus 4 squared, and the key is when you do that, when you FOIL that out, you always have the middle term. That middle term is always twice the 4 times x, minus 2 times that b. And so then the next thing is you factor that 3 through, you distribute the 3 through, and the last thing you do is you can simplify the constants, the 48 minus 5, and you get 43. Okay? So how do you reverse that? If you want to go from the completed the square form from the general form to the completed the square form, well, first thing you do is factor out the 7 out here. Then you factor out the 2 out of what's left so that you have x squared minus something times x. And you've left a space here. And in that space, you're going to take half of this 6. Let me change the colors here. You're going to take the 6 over 2 and square it is going to give you the 9 that you plug in here. And it doesn't matter if this is -6 or +6, because if it's -6 over 2 squared, it's still going to be +9. So you always add that b over 2 squared there. And since you added it here, you've got to subtract it here. So you didn't change the equation. But technically, you added this, don't forget that 2. You added 2 times 9. So you've got to subtract 2 times 9 out here. And so when you do that, the nice thing is this x squared minus 6x plus 9, that 9 has completed the square so that when you can factor that into x minus 3 squared. And then you just have to clean up your constants out the back. You've got -7 minus 18 is minus 25. And so when you're done, you get that. And from that, it's easy to see that the vertex is at 3, -25, which the graph shows it is. So if you can change that into the completed the square form, then it works out very nicely. Question is, how do you do that in general? How do you do that without numbers, with ax squared plus bx plus c? If this is your starting equation, do the same process. It's just letters. Factor out an a, so you get this b minus a in there. And what goes in here? Well, you take half of b minus a, which is half of b over a, which is b over 2a, and you square it, which is what we have right here. And then that was actually a times this. Don't forget that a constant out in front. So we have to subtract a times b over 2a squared. And b over 2a squared, if you look at it, b over 2a squared is just a times b squared over 4a squared, which is a times b squared, the a cancels out, which is b squared over 2a. Over 4a, which is b squared over 4a, which is what we have here. And so this then is the expression for when you've taken a general form of the ax squared plus bx plus c equation and you complete the square for it. And what's nice is this part here, this b over 2a, gives the formula that they have in the book. The x coordinate of the vertex is negative b over 2a. And in the book, they tell you to then find the y value of the vertex by plugging in f of negative b over 2a. Whatever that vertex is, plug it into f and you get it. Turns out it's always equal to c minus b squared over 4a. But I guess they figure that's a little bit more complicated and it's easier to just plug, once you know the vertex is at 3, plug in 3. Or if the vertex is at -0.5, plug in -0.5, rather than remembering this new formula. But both of those come from this completing the square process. when you want to find when the ball lands or when the profit is 0 or whatever, when you want to find when the equation is equal to 0. There are several ways you can solve that. One is if you're able to factor the quadratic formula or the quadratic function, then either the first term is equal to 0 or the second term is equal to 0. Or if you can complete the square, it turns out if you get it in this ax minus h squared plus k form, that's easy to solve for x, and I'll show that in an example. The third way is the quadratic formula. Opposite of b plus or minus square root of b squared minus 4ac all over 2a. And if you remember that formula, you can plug in your values for a, b, and c and find the two solutions, if they exist, and I'll explain that in a little bit, for where the zeros are for that polynomial, for that quadratic. So if you do it by factoring, so let's start with that formula we had before, 2x squared plus 4x minus 30. The first thing you want to do, most times, you want to factor out if you've got a constant out in front. You want to factor that out. And so we have 2 times, right here, 2 times x squared plus 2x minus 15. And if you can practice factoring, you've probably done that before. The 5 and the minus 13 should multiply to give you minus 15, and they should add to give you the middle term, 2x. So it's 5x minus 3x is 2x. So if you can, by trial and error, find those values of plus 5 and minus 3, you can solve that. And then the first term is 0 when x is 5, and the second term is 0 when x is 3. And so those do show up on the graph as the zeros. And one thing to notice is the vertex is exactly halfway between. So the vertex, we talked about this axis of symmetry. The vertex is here. The two zeros are equally spaced on either side of that. So what if it doesn't factor, or if you just don't want to factor? Well, one thing you can do is change it into completing the square form. And so if we take our equation and we try and set it equal to, or try and complete the square. If we take our equation, we've already completed the square and we showed that it was in this form. If it's in that form, we can set it equal to 0 and solve it easily. You add the 32 to both sides, you divide both sides by 2, and then you take the square root. And so you get x plus 1 is plus or minus 4. So x equals negative 1 plus or minus 4, which in one case is x equals 3, the other case is x equals minus 5, which are the two equations we had, the two zeros we had before. That's fantastic. So if you have it in the completed the square form, it's straightforward to solve for x. So what happens in general when you do that? And spoiler alert, you end up with a quadratic formula down at the bottom. So here's why that all that mess works. Completing the square with ax squared plus bx plus c, we said a few minutes ago, that's the formula you get. And what happens if you set that equal to 0 and solve for x? Well, you move this side to the other side of the equation, and so you get b squared over 4a minus c. Then you divide by a, both sides, and so that goes away. And over here, you get a 4a squared, and you get a c over a. And this, you can combine into a single fraction, and you start to get letters that look familiar from that quadratic formula. Then you take the square root of both sides, and if you change this, take that square root of 4a squared, it becomes just the 2a in the denominator. And when you subtract the b over 2a from both sides, you get this. And so that's beautiful. What that shows you is this part, just the first part, is the center, the symmetric line, the vertical symmetry of the parabola. That's where the vertex is, at minus b over 2a. And then this, we take the plus square root of b squared minus 4ac all over 2a, and that shows you how far to the right you go for 1, 0. If, on the other hand, you take the negative square root, that shows you how far you are to the left to get the other 0, and so there's a nice symmetry between the two. That's beautiful. And the last thing that I wanted to mention is this term called the discriminant, which is the b squared minus 4ac. And what that does, if it's it can either be less than 0, equal to 0, or greater than 0. If it's less than 0, you've got the square root of b squared minus 4ac, which is a square root of a negative number. That has no real solutions. So your parabola maybe does this. It's all above, or maybe it's upside down, and it's all below the x-axis. There's no zeros. What if b squared minus 4ac is 0? Then you have your line of symmetry, and your zeros are 0 to the right and 0 to the left. So there's really just the one point right here at the vertex. What if b squared minus 4ac happens to be positive? Then you do have a positive value to the right and a positive distance to the left to get two distinct solutions to your parabola equals 0.